Hello, in this lecture we're going to discuss absolute gravitational potential energy. How we can just calculate absolute gravitational potential energy. First of all, absolute gravitational potential energy is the energy that is needed to take the body out of the gravitational field. Now we know that around the earth there is a field which attracts things towards itself. Now that field is called gravitational field. To take out the body from the gravitational field, body must be in equilibrium. Equilibrium means acceleration must be equal to 0. Now the work done here would be variable. Why? Because we know that as body gets out of the gravitational field, more force is needed. A body is standing here, needs more force to go upwards. Now body standing here needs extra force to get upwards. Now that increasement of force is known as variable force. Now here is a structure that how we can just calculate the gravitational potential energy. Now we know that a body is standing here, denoted as RE, radius of the earth. A body standing at radius of the earth to the peak of the earth. The distance here would be preferred as R1. Now the work from R1 to R2 would be preferred as work 1. Just suppose this is a dr1. The body goes here R2. Now from this R2 to R3, the work done would be preferred as V2. Now from this to this would be preferred as V3. I have just made 3 steps, but there needs more steps to make the radius or distance of from R1 to R2 equal. If we got equal distance, equal radius, so we can calculate a proper value of the gravitational potential energy. Now, work N, Wn is needed to take body out of the gravitational field. Now, this is gravitational field and this is Earth. Now, how we can calculate that? First of all, the total work N is equal to work 1 from R1 to R2, work 2 from R2 to R3, R3 to R4 and so on till the work N, or we can say that Rn. Now we know that we first gonna only calculate the W1 to just get a constant. To get a constant. If we got a constant distance, force and angle, so we can easily calculate that. First, W1. Now we know that work is equal to F into d cos theta. Now here, the F with respect to gravitational constant is G, gravitational constant, ME, mass of earth, M, mass of the body, and R, radius square. Radius square means from the center of the earth to the peak of the earth. Here, the D distance would be preferred as R2 to R1. Now we know that W1 is equal to R from R1 to R2. So we're gonna take the difference in between them. So we're gonna subtract R2 from R1. We can simply put this. Now we know that a body is standing here. Now the gravitational force is downwards and the displacement cover is upwards. Now the theta here is 180. So we're gonna just simply write it as theta 180. Now here, as we know this R2 is multiplying here, so we can multiply it by distance too. So we're going to multiply it by distance. Now here cos theta or cos 180 is equal to minus 1. So the whole value of G would be taken as minus. Now here we know that R square, the distance from here to here and distance from this body to this body, would be taken as R1 to R2. If we multiply these both values, we will get R square. So in the place of the R square, we will just write R1 multiplied by R2. R1 multiplied by R2. Now let's move to other equation. Now here we're gonna just multiply the R1 and R2 from both R2 and R1. Now here this R2 would be cancelled with this R2, this R1 would be cancelled with this R1, and we will get 1 upon R2 minus 1 upon R1. We have just set it because we know that the greater value is R2, so we have just transferred it here. Now we will just put this equation number 1. We got the proper equation for that. Now we are gonna just put this equation and follow this process for R2 and equation number 3 also. Now when we combine all the equations of W1, W2 and W3 and so on, so we will get this equation. Now here we know that capital G, mass of the earth and mass of the body is constant, so we're gonna take it as a common. Now this is all the equations left. Now we know that negative R2 would be cancelled at positive R2. Now how this becomes? Because we know that R1 minus R1, 1 upon R1 minus 1 upon R2. Now here this value would be as minus, and minus into minus is equal to plus. Now that's why this becomes plus. Now this plus positive R3 would be cancelled at negative 1 and so on until we got this value. Now this value is also in minus. Now we will only got R upon R1 and R upon Rn infinity. Now here we know that the body that is above from the gravitational field would be taken as infinity. Would be taken as infinity, so we're gonna just remove that. And this equation can be used to calculate the absolute gravitational potential energy. And this is all about today's lecture.